Welcome to Properties of Exponents. As a reminder, there are 5 properties or laws of exponents that allow you to simplify various exponential expressions. Here's the first one. This property states that if you're multiplying two of the same bases and each of those bases has an exponent, you keep the base the same, but you add the two original exponents. Here is number 2. This one states that if you're dividing the same bases, you keep the base the same, but their exponents are being subtracted from one another, and it is very important to keep in mind that the top exponent will come first in your subtraction. So you will be subtracting top minus the bottom exponent, even if that results in a negative number. For example, if you have x to the power of 7 over x to the power of 9, you keep in your base x the same, you're subtracting 7 minus 9, which results in x to the power of negative 2. So even if that leads to a negative exponent, you're still going the top minus the bottom. Here is number 3. This one here only has one base a, but that base has two separate exponents, one on the inside and one on the outside. If that's the case, you're keeping your base a the same, but you're multiplying the exponents. Here's your number 4. Number 4 tells you that if you have the base a and that base has a negative exponent, that negative exponent must become positive, and for that exponent to become positive here, you have to flip the base. Here's an example. So the original base was x. I reverse the base or reciprocate it or flip it, make it 1 over x, and that makes the exponent of x to be positive. Another example is, in this example, your x is at the bottom of the fraction with a negative exponent. You will need to make that 4 positive by placing x to the top of the fraction or flipping it, and that makes your exponent positive. Couple of things to keep in mind with this property. In this example here, your x has the power of negative 4, which requires us to make that 4 positive by placing the base of the exponent x to the top of the fraction. Notice that the 2, which is already on the top, does not have a negative exponent, so you should keep it where it was without flipping. Only flip what is impacted by a negative exponent. Here's another example similar. So here, as you see, you have an x that is impacted by a negative exponent, a y that is impacted by a negative exponent, and a 2 that is not. So only x and y will be flipped, which means y will go to the top and the exponent will become positive. X will go to the bottom, which will make the exponent positive, but 2 will stay where it was. A final example for this property is this. Lots of times, students try to make the 3 positive, which is exactly what you should be doing, because we do not want the exponents to be negative. But I also often see for students to try to make this 2 that is currently negative into positive. The 2 is negative, but it has no negative exponent. So please keep the 2 as is, keep it negative, and only flip what is impacted by a negative exponent. And the last and final property is if you have a letter or a number that does not have an exponent, you can always make that exponent a 1. And if you have a letter or a number that has a power of 0, that becomes a regular number 1. not the exponent of 1, it just turns into a number 1. Let's look at a few examples that will ask you to simplify your exponential expressions. When you're simplifying an exponential expression, keep in mind that you have to first make sure that you have no fractions that can be simplified. You have to make sure that all coefficients are multiplied. You have to make sure that you have no repeated bases. This means that your expression should not have two separate x's with exponents or two separate y's, etc. And finally, you should have no negative exponents. Keeping all of these rules in mind, let's look at a few examples. So in this example, you have two coefficients, a -6 and a +6. It's multiplication, so we'll go ahead and make that a -36. And then you have two letters, a W and an N. These are different bases. None of the properties will be applied because all of the properties require you to have the same basis if you were able to combine these two into one. So you just keep a W and an N and you're done. For this example here, you still have two coefficients, a 5 and a 2, and we need to make sure we multiply those into a 10. And then you have two bases that are the same and they have exponents. And this is also multiplication. When you're multiplying the same basis, you're adding the exponents, keeping the base the same. So the exponent of x will be a 7 because you're adding a 3 and a 4. And remember, as long as you have no fractions left to simplify, you have no coefficients left to multiply, you have no repeated x's or y's, and you have no negative exponents, you're done. Here's another example. You have a fraction inside of the parentheses with an exponent on the outside. Please be mindful that the 5 on the bottom has the power of 1. If you don't have an exponent, you can always add that 1. And based on our property 3, we will be multiplying the 4 by every exponent on the inside. So z will now have the power of 12 because 3 times 4 is 12. And 5 will now have the power of 4 because 1 times 4 is 4. Now, 5 to the 4th, we can multiply it on our calculator. That's 625. And then z12 will have to stay as z12. Again, check that you have no fractions to simplify. You have no coefficients left to multiply, meaning two separate numbers. You don't have any negative exponents. You don't have repeated letters. You're done. Again, in this example, you have a coefficient of -4 and the v with the power of 19. All of that is on the inside. Keep in mind, -4 has that exponent of 1. And the 2 on the outside will be multiplying every exponent on the inside. So my -4 will now have the power of 2, and my v will have the power of 38. -4 to the power of 2 can be calculated just like 5 to the 4th here. So -4 squared is 16, because that's -4 times -4, v to the power of 38. Here's your number 5. You have a fraction, and the repeated bases are here and here. If you have repeated bases in a fraction, we subtract the exponents. So for the x's, you're going to have the power of 33 minus 19. Keep in mind that's top minus the bottom. And for the y, you're going to have the power of 68 minus 29. So x has the power of 14 and y has the power of 39. Here's your number 6, which looks very similar to number 5 with the addition of this 8 over 4. And that is the case where you have to make sure that all of the fractions are simplified. 8 over 4 becomes a 2. For the x's, you will subtract the exponents, so x will have the power of 8 minus 5, which is a 3, and you will do the same for the y's, so y will have the power of also a 3, because 7 minus 4 is also a 3. That's it. You have no coefficients left to multiply, you have no fractions left to simplify, no negative exponents, no repeated letters. Here's an example of multiplication again, where you have two coefficients, the 3 and the 7. You will multiply them and make it a 21. And then you have two separate z's with an exponent of negative 8 and then a 3. Based on our first property, we will be adding the exponents, so z will have the power of negative 5. Now, this is an example where you have to take care of the negative exponent. You should not leave your problem with the negative exponent. So 21, notice, does not have a negative exponent. It's a regular number, leave it alone. Z, however, needs to go to the bottom of the fraction, and that makes your exponent positive 5. So 21 stays where it was, but Z travels to the bottom to make that exponent positive. So here's another property. You got an x to the fifth on the top and x to the fourth, which is also impacted by this power of 6 on the bottom. Property number 3 tells us to multiply 4 by 6, so I will do that first. I will keep my x to the fifth on the top for now. So on the bottom, you will have x to the power of 24. Now you have two repeated x's, which you have to combine into one. This is the same property as we had in number 7. That requires us to subtract the exponents. Now keep in mind that you will be subtracting top minus the bottom, although the bottom is bigger. So this will result in the negative exponent of 19. And then you have to make that 19 positive by placing the x to the bottom. Now you're done. Here's my final example. 9 to the power of 0 over g to the power of negative 6. Keep in mind that 9, or anything for that matter, to the power of 0 will turn into a regular number 1. It has no exponents, so whatever is impacted by the power of 0 becomes a 1. Now, I'll keep the g to the power of negative 6 here for now. G to the power of negative 6 needs to become g to the power of positive 6. It's already on the bottom, so to make that 6 positive, the g and the 6 will need to travel to the top. The 1 will not move. It will stay on the top because it does not have a negative exponent. So it's 1g to the power of 6, or you could just write it as g to the power of 6 because coefficient of 1 can be avoided.